Hello, everyone, and welcome to today's webinar previewing SAM's new solar resource data download features. I'm Paul Gilman, and this webinar is the second in our series of 3 webinars this year. And this year we've done things a little differently and using the webinars as an opportunity to introduce you to new features that we're developing in SAM a little before we've actually released the version that has them. So last month we had a preview of the new PV bifacial model, and a recording of that's now available. And next month we'll be talking about a new multiple MPPT inverter model that will be part of the model. And by October 18th, we may have released the new version, or we'll be real close by then in any case. So you can find recordings of old webinars and information about upcoming webinars on the SAM website. For those of you who might be new to SAM, I thought I'd give you a quick introduction. So it's a desktop application. It's free software, and it's designed to model renewable energy systems. And it includes both a performance model and a financial model. So you can do techno-economic analysis of renewable energy projects. It's developed by the National Renewable Energy Laboratory with funding from the U.S. Department of Energy. We make versions for Windows, Mac, and Linux. And generally, we release about 1 or 2 new versions each year. The desktop application is one way to use SAM, but we also have a software development kit, which is for computer programmers who write their own applications. And it provides access to an application programming interface, or API, that developers can use to interact with SAM from their own computer programs. SAM is an open source project, which means that the source code is available to the public. So you can explore the source code to see how SAM calculates things. You can build your own version of SAM if you like. You can help us out by making your own contributions to the model if you're a C++ programmer. And we also provide user support via a help system. So we have a help system built into the desktop version of SAM. There's a lot of documentation on the SAM website. And we also have an online forum and email address that we use to interact with folks. So you can find out about this and more on the SAM website at sam.nrel.gov. I'm going to be discussing a new feature today that's in this SAM beta version. So if you're interested in trying it out, you can download this version. This is a beta version, so it has some bugs and is not fully documented, and it will expire in about a year. So the idea is that you would run this beta version side by side with the current version of SAM if you're using SAM, and just use the beta version for testing rather than for generating any results that you'd be using for anything. If you do decide to help us out with the beta version, we appreciate any feedback, and you can use the support forum or the email address to contact us with feedback. I also put a link to the download link in the chat box, and I'd also mention that I uploaded a PDF version of these slides that has all these URLs and other information in it, so you can download that from the handouts. All right, so today we're going to start with a brief discussion of how SAM uses weather data, and then I'll introduce you or re-familiarize you with the NSRDB, NREL's National Solar Radiation Database. And I'll explain why we made the changes that we've made to the location and resource page, then demonstrate the features and show you a couple of other tools that you might not know about that are available in SAM for working with weather data. And with whatever time's left, we'll have a Q&A session. Speaking of questions, if you do have a question, please feel free just to type it in the question box, and my colleagues will be monitoring and answering it, or I may pause now and then to see if there are questions that are relevant to what I'm talking about and answer them as I speak. And yes, we are recording the webinar, and it will be available on the webinars page of the SAM website. All of our webinars are available there. Okay, so we're focusing on solar resource data today. And SAM's got several different solar energy models, and they require different hourly or sub-hourly data in the weather file. So here's a summary of the weather data that the photovoltaic and concentrating solar power models require. There's also solar water heating and high concentrating photovoltaics that have different weather data requirements. So the different solar models need different data. And SAM has some tools for calculating data from a weather file. So for example, if SAM, the PV model needs diffuse horizontal and direct normal irradiance, but if your weather file has global horizontal and diffuse horizontal, SAM can calculate the missing component. Just wanted to make you aware that the weather file is used differently by the different energy models in SAM, and you can read more about all of this in SAM's help system. This is a graph of data from a weather file for the PV model. So on the top, we've got irradiance data, the beam and diffuse irradiance data in watts per square meter. And then we've got temperature and wind speed data on the bottom graph. And you'll see that this is 1 year's worth of data. So it goes from January to December. And each vertical line in that graph represents a single hour. So this is hourly data. So you need at least 1 year's worth of data, and it can be hourly data or it could be sub-hourly. So if you have 1 minute, 5 minute, 10-minute data, you could use that in SAM. This is what a weather file looks like. It's just a text file with comma delimited values, so a CSV file. And the SAM CSV format that SAM uses to read weather data is just a simple CSV format. And if you've been in solar energy modeling for a while, you'll know that there are various other file formats. The SAM CSV format has some benefits over some of the others. It's easy to edit using spreadsheet software or a text editor. It's easy to create the files from a script, so you can use your own custom data. Or if you have weather data that's in another format, you can write a script to convert it into the SAM CSV format fairly easily. The format is also flexible, so SAM can determine what data is in each column from the column heading rather than the position of the column. So that means you can put the columns in any order when you're creating the file. And then SAM ignores any columns that are in the file that it doesn't need. So you may have a reason to build a weather file with some extra columns if you're doing validation or if you're comparing different data. You can include extra data in your file. And it's also the format that the NREL NSRDB uses. So when you download a weather file, it's in the SAM CSV format and ready to use in SAM. SAM does also read other weather file formats like the Energy Plus weather format. That's for the Energy Plus building simulation software, and the older TMY2 and TMY3 file formats. I want to take a quick minute to talk about typical year and single year data because I'll be referring to it later. So a typical meteorological year file is a file that's 1 year's worth of data that represents a historical period of many years in the past. And it's built by taking months from each of the years in the record, in the historical record. So the TMY file might have January data from, say, 1998, and February data might be from 2002. And so each month is chosen based on being the most representative of all of the Januaries, for example, in the historical period. And this way of constructing the file makes it possible to have a single year file that represents the historical period, but where all of the columns of data are all consistent with each other. So the solar irradiance data is consistent with the temperature data, is consistent with the wind speed data. A single year data file is just a file that contains data for a specific year. So it might be weather data for 2015 or weather data for 1998. You can read more about typical year and single year data, and again in the help system. And the help system has descriptions, also has references to documents outside of the help system. So the National Solar Radiation Database is a collection of weather data for the regions of the world, sort of colored in this map. So got a lot of countries in the Western Hemisphere and some countries in South Asia. The Western Hemisphere data, the latest data is called PSM v3 data, and the South India data is called SUNY data. They're two different data sets, and they have different spatial resolution and use different processes for generating the data. There's a webinar that was done this morning by the NSRDB team that we'll link to on our SAM website that you can watch if you're interested in learning more about the NSRDB. So you can use the NSRDB's online data viewer on their website to download weather files. So you pick up a spot on the map, and then you follow some instructions and get a file for that location. Or you can just do it directly from SAM, and that's possible in the current version, but we've made it easier by adding some features in the new version of SAM. Here's what you'll be able to do in the new version of SAM. You'll be able to get the latest NSRDB data. That's the V3 data for the Western Hemisphere, and then also the SUNY South Asia data. You'll be able to download both either typical year data or single year data files. If you're doing P50, P90 analysis and need a set of weather files for different years at a given location, you'll be able to download those. And then you can still get the old TMY2, TMY3 data if you have a reason to use that older data, maybe for comparisons or some other reason. We're going to continue working on the solar resource download features. One thing that we're hoping to do is to make it possible to download data from the PBJIS, which is another database that's maintained by the European Commission for locations outside of the NSRDB area. Maybe streamline the P50, P90 simulation process. The NSRDB data is available in either 30-minute or 60-minute time steps, so we may switch over to 30 minutes by default. And we're always open to suggestions for new features. What I'm showing you today in the beta version we know will be in the next release next month. We may sneak in one or a couple of these other features if we have time, or we may add them in as an update. As those of you know who have been using SAM for a while, when we release a version of SAM, we typically have a period of a few months after the release where we're releasing updates to fix bugs and in some cases add some features. So we may be able to add some of these features as a patch or in the next version of SAM. So before I continue with the demonstration, I just want to familiarize you with some terms that I'll be using and that I also use in my communications with user support and in the documentation. So we've talked about a weather file. I'll talk about what a weather file folder is in this context, the solar resource library, and then the default weather file collection. So we talked a lot about weather files already. There's the text file that contains the weather data. A weather file folder is just a folder on your computer that contains weather files. So there's tools on this location and resource page to add and remove weather file folders. On the top of this little window are weather file folders that you add, and then this is a default one that SAM creates when you install SAM, which you can also change, and we'll see that later. And now the Solar Resource Library is a list of all your weather files. So when you start SAM the first time, it builds the Solar Resource Library by scanning all of the files that are in your weather file folders. And the benefit of using the Solar Resource Library is that if you have different versions of SAM installed on your computer, they'll each scan the resource, the files in your Solar Resource folders, and create a library. So it makes it easy to access the same weather files from different versions of SAM. In the process of building the library, SAM checks the weather file for errors, which can be helpful for identifying problems with your weather file. And then when you select a file from the Solar Resource Library, you see header and summary data right in SAM, which is useful for understanding what weather data you're working with. And for those of you who are interested, the Solar Resource Library is actually just a text file that's stored on your computer's application folder. I'm moving through these slides relatively quickly. You can download them from the handout section, and they'll be made available with the recording, so you can refer to them later. Okay, so this is a screenshot from the location and resource page where you can see how you choose a file from the library. We can see 3 of the files in the library, and then there's a list of the weather file folders that SAM uses to build the library in that blue box below the library. And then here's just showing the weather data summary. So when you choose a file in the library, then you see the summary down below. And the global horizontal, normal, direct normal, diffuse horizontal values here, these annual averages, are values that SAM calculates when it builds the file, when it builds your Solar Resource Library. So you get a nice little summary, and you can check these numbers to make sure they look reasonable. And then this is the information from the header and the first couple of rows in the file. You old SAM hands, some of you may be disappointed that the choose a weather file from your computer is gone. We generally try to avoid making such dramatic changes to the user interface, but we really think it's better to work with the Solar Resource Library as a way to manage your files. So we've removed that input from the location and resource page. If you're an LK scripter, the variables associated with these inputs are still available, so you'll still be able to work with those. And some of you, again, may have been using the Solar Resource folder that comes with SAM. It's in the SAM installation folder. And again, we recommend that you don't use this folder to store your weather files, because when you uninstall SAM, you might lose the files that you added if you're not careful. And the files in that folder are not available between different versions of SAM. So if you put them in your SAM library, then you can always access them from different versions and across installations. And then we still have this folder. So the purpose of the folder now is just to store a handful of weather files for the default configuration. So when you create a new file in SAM, it creates, for example, a residential PV system is always this 4 kilowatt system in Phoenix, Arizona. So we've got a Phoenix weather file in the Solar Resource folder for that purpose, just for those defaults. So it's just a small folder now, and it reduces the size of your SAM installation significantly. All right, so enough talk. Let's have a look at this thing. Maybe I'll pause and see if there's any questions worth mentioning. It looks like Nick and Steve and Janine are all busy helping out here with the questions, so I will carry on with the demonstration. So let me switch over to SAM. So this is the beta version. Sorry, I need to rearrange some windows here. So I'm giving you the demonstration from the version that you can download and play with yourself. All right, so the first thing is just the most common way that you'll use the location resource page is to download a TMY file for some location, right? So I can, let's say I'm going to download a weather file for NREL. So there's NREL street address. I type the street address in there, and then I just type download and add to library. And Sam does some stuff in the background. And then when it's finished, it shows me the SAM download weather files folder with the weather file that it downloaded. So here's my CSV file. And you'll see that it's named based on the street address that I typed in there. And it also adds some other information. There's the latitude and longitude. So when you download a weather file, what it does is it takes the street address and uses the Google Mapping API to find the latitude and longitude associated with that address. And then it sends that latitude and longitude to the NSRDB to find the weather file that's associated with that location. So the latitude and longitude here is the one that's returned by the Google API. And then this is information about what type of data it is from the NSRDB. It's the PSMV3, 60 minutes, TMY. So you can confirm that it downloaded the right file. And if you want, you can open the file and have a look at it. Sorry. Got too many things open here. There. So that's the weather file. And then there's also this log file here in your downloaded weather files folder. And if you open that, this is a running log of all of the downloads that you've ever done from the NSRDB. So if you go down to the very bottom, you'll see the last one. This download was today at 11 o'clock my time, and it tells you the address. There's the address I requested. I guess it's this one here. And then the TMY file, and here's the URL that it used to download it from the NSRDB. It took 6 seconds to download it, and it passed the weather file check. So this log is useful if you're downloading a lot of weather files. You have a record of what happened, if there's any problems with the download, and it's useful if you're communicating with us about trouble with the downloads. You can send us this log file, to help us troubleshoot. All right, and then back in SAM, we can find our file that we downloaded and choose it, and then run a simulation, and we're ready to go. So that's probably going to be your most common workflow, is just downloading a TMY file. I did a complete street address. You can do just a place name, so I could do Golden, Colorado. Or you could do a latitude-longitude pair, so I could say 45 degrees north and minus 110 degrees. Any one of those will work, as has always been the case. All right, the next thing you might want to do is, instead of downloading a TMY file, is download a file for a particular year. So let's try that. I'll do that this time for Portland, Oregon. And instead of a default TMY file, I want to choose a year. And then click download. And this little window pops up. These are the years that are available for that address from the NSRDB. So you can get the TMY file if you want, or we can choose any year between 98 and 2015. So let's say I have load data for 2013. So I want solar resource data for that same year, so my bill calculation will be more accurate. So I choose my year, and then it's off and running, and there it pops up the downloaded weather files folder, and there's my Portland, Oregon file with data for 2013. And I can choose it from the library. So when it downloaded the file and added it to my library, it also ran the file checker to make sure that it was a valid file, and it's ready to go. Another scenario might be that you have a bunch of locations. So maybe you're an installer and you're working with on quotes for 5 customers. So you can sit down with Sam and choose multiple locations instead of one location. And so when you do that, this Edit Data button appears. So you click that, and then you can type in a list of addresses or latitude and longitude pairs. If you've got 10 locations, you can do 10 values, and then just type your location in each one. You could also import a list of locations or street addresses or latitude longitude pairs from a text file. So let's say we wanted to do that. What I would do is create a little example list here and then export it just so you can see what the format looks like. So I'll go to Desktop and I'll call this location. I already have it, so let's save that. So I'm just exporting this location list so that I can see what the file format looks like. Desktop, and there it is. So it's just a list of locations. It's just a text file with one row for each location. So I could add one here, save that, and then import it. And there's the address came right in here. So if you've got a list of locations, you might have a big database of latitude and longitude pairs. You could download weather data for that directly from SAM. I'm going to cancel this because the download can take a while for a bunch of different locations. But when you do enter that list of locations, you can also either choose a year or default, download the TMY file. Each of these options for the list of locations. All right, another scenario might be that you want to do P50, P90 analysis. So for P50, P90 analysis, what you do is you go down here under Simulate, click the P50, P90 button, and instead of running a single simulation, you're going to run a series of simulations. You're going to run a simulation for each year over some period. And then Sam's going to report a P50 and a P90 value for a bunch of outputs. So let's see. This, for example, I have a folder here that contains a bunch of weather files for Golden, Colorado. Here's what it looks like. And actually, this is not a good example. But in any case, you need a folder with a bunch of different files with the year in the file name, so Sam can identify the year from the file name. I'll find a better example. Bear with me here while I click through my folders. Okay, so here's a folder that has a whole collection of years, and then I click Run, and I need a different one. Sorry. Okay, that's not going to work. But those are the steps. Is you have a folder with 10 or more weather files in it. Each weather file has a year in the file name, and then you run P50, P90 simulations, and you get a bunch of results. If you want to download P50, P90 data for a particular location, you put your address in here, and then you choose Download Files for All Years. and then you click download. And that does take quite a while. I think there's 18 years of data in the PSMV3 weather file or collection. So you'll get a file for 1998 through 2016. And so you probably want to set that going during your lunch break or something. But when you're done, you'll have all of the files that you need. It'll put it in a folder, in its own folder, and it also downloads the TMY file for that same location. So then you can compare your P50 results with your TMY results, for example. So for those of you who are familiar with P50, P90 analysis, that should all make sense. All right, and then the last thing you can do is download legacy data, so the old TMY2 or TMY3 data, or 30-minute data that's available in the latest NSRDB data set. So you choose that legacy and 30-minute advanced option here, and then click download. And this opens the old weather download window that we have in the current version of SAM. So you put in a street address or latitude longitude pair here, click search, and then it returns a list of this is all the data that's available for that location from the NSRDB. So you've got 30-minute data, 60-minute data, you've got PSMV2 data, PSMV3 data, TMY3 data. So you've got 3 different data sets, and you've got 30-minute and 60-minute data for PSM, and you can even get the historical single-year data from the old TMY3 data sets. So there's a lot of data here. You've got some tools here to select different data sets. We'll have to make a couple of updates to this for the release, but this is the sort of multi-tool weather file downloader in SAM. It allows you to download anything that's available in the NSRDB. All right, and then the last thing I wanted to show you is how to manage your weather file folders. So let's see. If we go up here, there's this AddRemove Weather File Folders button. And when you first install SAM, it'll just have this one folder, which is the SAM downloaded weather files folder. So when you install SAM, it creates this folder in your user folder. So you can either continue to use that folder. If you want to change it to something else, you can just choose a different file. So this is where anytime you use one of these download buttons, that's where the files are going to end up. But you can also add other folders. So I've got a few examples that I set up on the desktop here. So here's this test data folder, for example. I'll select that. And then when I click OK, SAM scans that folder and adds the files to my solar resource library. It also tells me that it found a couple of bad files in there. So these are CSV files, but they turn out not to be SAM CSV files. So those do not get added to the library. And then my library is now updated with those additional files. So if we take a look at that folder, test data. So this is a file that I downloaded from PBJIS, and it just has, it's a weather file folder, but it's not a SAM CSV folder. The timestamp is in the wrong format. It doesn't have any column headings, and so SAM doesn't recognize it. So your weather file folders can have folders that are not SAM CSV folders. They'll just be ignored. We can also download or include, this is a folder that I created that has some files in different formats. So this is in the EPW format. And this is in the old TMY2 format, which is really hard to read if you're a person. But all of those file formats are acceptable formats to SAM. So if I add that folder, different formats. All right, so now I have 2 different weather file folders, and I add that. I already added that. I just click OK. It found those same 2 bad files. Now I have 3 weather file folders that are being scanned, and my library has those different format files. And you click on it, you can get your weather summary here, and you can look at graphs of the data in that weather file. And then the last thing I wanted to show you, for those of you who are not in the Western Hemisphere or South Asia, is there's this PBJS weather data set that I mentioned. And you can get to that by clicking this link here. It says go to SAM website weather page. And the SAM website weather page has a link to the PBJS website. And so here you can download a weather file for Europe, Africa, much of the world. So let's say I have a project in Lubumbashi, Zaire. All right, so it's right there. So I click on it here, and then SAM can recognize EPW file format, so I'm going to download an EPW file. So off it goes. It's downloading, and it put that in my downloads folder. So let me try to find that. And okay, there's the file. So I'm going to copy it and put it in my SAM downloads folder. I can put it in any of my weather file folders. All right, and then I go back to SAM and refresh the library. And there's my file. And I have some summary data. I can look at the data. And I can run a simulation. So that's how to get data from the from PBJS. It's and as I said, hopefully we'll make it possible to just download those directly from the page. But for now, you can at least go to the website. For those of you who do that, I will mention that their EPW format files don't have need an additional line at the end of the file. So let's see, if I go to my downloads, and open it in text editor, and I'm going to look at line endings. And go to the very last line. So this file doesn't have a line ending for the last line. So that will actually cause SAM to crash, or not to crash, but to flag an error. So let me use this file, SAM downloaded files, and yeah, okay. And then refresh the library. Okay. Yeah, that's working. It won't. It's not loading. Well, let's see. I guess there's 2 files by the same name, probably. Yeah. So let's see if I tried this one. Yeah. So this file, if I try to view the data, I get an error here. And if I run a simulation, it doesn't work. So if I go to macros here, we have a bunch of tools that you can use to manipulate weather data prepared as macros. And there's one here called the Solar Resource File Checker. So I want to check that EPW file to see if there's something wrong with it. So I'll run the macro and find the file. And run it, and it says data line formatting error at record 8759. So this is saying that you need to end a line in that file. So if I go to the file and hit return at the end, so there's a end of line, then the file will work. So this Solar Resource File Checker is a useful macro when you're using working with weather data from different sources. You can use it to check the data. It's not bulletproof, but it will help you identify some issues. There's also the Solar Resource File Converter. So you can convert from these 4 formats into SAM CSV. You just choose the format here, and then run the macro, choose the file, and it converts it. And then in situations where you might have, let's say you've got 15-minute load data, you're doing some demand charge analysis, and you need 15-minute weather data, this interpolation macro runs a little routine that just converts an hourly weather file into sub-hourly weather file, so that you can at least get some simulation results that show the PV system interacting with that 15-minute load data. So you can set the time step to be the same as whatever's in the load data, or you can choose a time step, and then it just interpolates between the hourly data values to come up with sub-hourly data. So there are a bunch of other tools here that might be handy for other applications, but your solar resource related ones are all listed here at the bottom. And to get to this page, you click macros here under simulate. And I think that's all I had. Yeah. So we've got a few minutes left. I can answer questions. If there's anything else you'd like me to demonstrate, I'd be happy to. Nick, Janine, Steve, was there anything that jumped out at you that I could explain?
Hey, Paul. Yes, there were some questions on how SAM handles leap days. Might be worth speaking broadly to that.
Yeah. So right now, SAM doesn't model leap days. So if you download data for a leap year, it will model. It'll model in 8760. So if you've got an hourly data set, it'll model it as 8760. It won't account for the leap year. I think we're still debating about whether we're going to remove February 29th or truncate December 31st. But yeah, this is now that there's more and more data available, and that these annual data sets are available, like from the NSRDB, you can download. There's a switch where you can download leap days or not. So it's actually possible to download, a multi-year data set that has leap days every 4 years. And obviously, it makes sense to run the model using that data if it's available. But it requires making some updates to how SAM calculates things. So that's something in the future we'll we'll be sorting out. Another related thing is, instead of simulating, just running a 1-year simulation and then basing the cash flow calculations on that 1 year, why not just run a simulation for each year of the project life? And again, now with all this single year data available, the data is available to do that, and our computers are pretty fast. So, maybe it makes sense to switch to that model of simulation. So again, something else to watch for in the future.
Thanks, Paul.
Yeah.
There were also a handful of questions about P50, P90 analysis that might be worth just sort of going through what SAM does and calculates.
Yeah, let me find. Yeah, there it is. Okay. I was in my haste while I was talking and clicking, I couldn't find the right folder. But so in my let's see, in my SAM weather download folder, this folder here was created earlier. I downloaded this data earlier today. So I typed Golden, Colorado here, and then I clicked download files for all years, and then I went and got a cup of coffee, and I came back a while later, and this folder was in my SAM downloaded weather files folder with all these single year weather files from 1998 to 2015, and this well, it's not there now, but there's a Golden TMY file, so I might as well just get that now. So the way a P50, P90 analysis works is you go to P50, P90 here under Simulate, and you choose a folder that contains a set of single year files. So that's in my SAM downloaded. Okay, there's that folder. So I select the folder, and then when I click Run Simulations, it's going to run a simulation for each of the years from 1998 to 2016, I guess it was. And then it shows these P10, P50, P90 results for a bunch of metrics. So if we look at the annual energy, here's the P50 value and the P90 value. So the P90 value means that over the 18-year period that we simulated, see, I have to be careful to say this right. The annual energy was 68,000 kilowatt hours per year, or less 90% of the time.
I think it's or more.
Or more.
Always confusing.
So this the P90 value is a more conservative value than the P50 value, which is basically an average value. If we go to, let's see, if I go back to the location resource page and do the Golden, I got to refresh the library. Okay, here's the TMY file for Golden. The annual energy, the TMY annual energy value is 7115 kilowatt hours. I can compare that to the P50 value, which is a little lower, but pretty close. We have in the presentation, I have a link to a video where we talk about P50, P90, the steps. So there's a video demonstration of that. That's just a short little one. And if you go to the SAM website, webinars and videos, this is the short how-to video. If you want to watch, I think it's me, go through those steps again to see how to work it. And then we have a presentation on P50, P90 simulations somewhere in, I think it's, obviously we need to organize this a little, yeah, parametric and statistical analysis. This presentation kind of talks a little bit more about the theory. All right. Any other questions?
Yes, there are a couple others. I'll just keep
Great.
throwing them out here. There was a question on snow data, if that's still from the old TMY2 data set or if it has been updated.
Do you happen to know, Janine?
Yeah, I believe that there's not snow data in the latest NSRDB PSM v3 data, which is what we pull from SAM. So in order to get files with snow data, I believe you would still have to use the old files underlying the TMY2, which is now also called the MTS1. Is that right, Paul? Which, yeah, as Paul is showing right now, you can download by selecting the legacy and 30-minute files and looking for the MTS. Oh, MTS2. Is that right?
No, MTS2 is TMY3. So the thing about the TMY2 data is that it's not available for, it's only available for 239 locations. So let's see if I can find a location that has it so we can see if there's snow data in it. But yeah, snow data is not readily available in a lot of the data sets.
Yeah.
There we go. All right, so let's try this. Uh-oh. Looks like we have a little bug here. All right, here it goes. Yeah, so we'll check and see if there's snow data in that one. Oh, here it comes.
Another thing to mention while Paul's opening up this file to see if it has snow data is that we did do a analysis on a couple of different typical system configurations across the continental US and looked at sort of starting point average losses for a lot of locations using that old MTS1 data for all 239 locations. And that report, I believe, is linked on the SAM website if you search for snow on the website. So that can also be a resource for what you could enter for snow losses.
All right, well, we'll have to, let me just look at the weather file itself and see. If there's snow data in it, although it's the TMY2 format, which is hard to read. Oh no, it should be in SAM CSV. Okay. I do not see snow data there. So we'll investigate that. If the data is available, we may need to tweak the code here to make sure we're downloading it. But as far as we know at the moment, yeah, the TMY2 data is where, or the MTS1 is the one that has snow data. I see. Yeah.
Oh, go ahead. You probably see another question that needs to be answered.
Right. I saw one about source for other areas in Asia. There are a number of data source weather data providers. So if you go to the weather data page in SAM, these are the two data sets that are free that we have worked with. We've got a list of other data sources here. Some of them are free and some of them are commercial products. So you can explore some of these data sets if you're looking for locations outside of these zones. And does SAM include losses due to snow ice sticking to the panels based on their mounting angle? Maybe Janine is in the process of answering that one. But that's a little off topic. I guess you answered it. You just explained that there's some resources. We did a presentation on the snow model, right?
There should be. If not, there's a paper that describes the implementation of the snow model, which does include a temperature threshold for melting. So in some ways, yes.
Yeah, and that's only for the PV model, and it's
yeah.
Okay.
There are also a handful of questions generally about accuracy of weather data that I don't know if you want to dig into a little or if you want me to tackle, Paul.
Yeah, there's in the presentation this morning from the NSRDB, they talked about accuracy and sources of error and so on. So that might be, if you're really interested in learning more about it, that might be a good place to go for some details. But Janine, maybe you can summarize it.
Yeah, I don't recall the accuracies themselves off the top of my head. I know that they do have published accuracies for each of the components of irradiance, or at least published estimates of the accuracy. And there are a couple of questions about comparisons between different weather data sets. I'm sure some of those exist, but that's a little bit outside of what our team does. So we may not be the best persons to ask those questions. But if you hunt around a little bit on the NSRDB website, I'm sure you can find more information on the validation they have done.
Yeah, and that is a big topic. And the fact that you can use data from different sources in SAM means that you can do some of your own comparisons. So if you're, if you're focused in on a particular location and maybe developing a project or doing some analysis for a given location, if there's data available from different sources, it's not a bad idea to just run simulations with the different data and see how different they are. And if you get sort of fairly similar results across all the different data sets, then you can have a higher sense of certainty. Then if there's a lot of variation, then that might suggest that there's either problems with the data or there's something about the weather in that location that affects the solar resource. So.
Great. I don't see a whole lot of other questions other than people wanting to be reminded when the new version is going to be released and where this will be posted. Sorry, this being the recording of this webinar.
Right. So here's the webinars page on the SAM website. This is where we'll be posting the recording. And we're working hard on the next version now. So we hope mid to end October. But it depends on what comes up between now and then. But what we're shooting for that time frame. And if you have the PDF file of the presentation slides, there's at the very beginning is the URL to download the beta version if you wanted to play around with some of the new features, the bifacial module, bifacial PV module models in there, and these new solar resource download features are also in there. All right. Well, with that, I think we'll wrap it up. If you have any questions, further questions that we didn't get around to answering, please feel free to post them on the SAM support forum or to use the contact form where you can find our email address. I will mention, if you post something on the support forum, you'll need to register to log on to the SAM website, and your post won't appear immediately. We have to approve it before it appears. So if you post it and you don't see it right away, don't worry, we'll get to it. All right, with that, I think we'll sign off. Thank you all very much for signing in today, and we look forward to hearing from you sometime soon. Goodbye.